Hello everyone, welcome to Unacademy JEE English. So today we are going to cover graphs in kinematics, and this is lecture number 1, and it will be a full length lecture where we are going to cover all the aspects of graphs in kinematics. So here some information is a required equation of motion, which I think almost all of you will know. In constant acceleration, or when acceleration is 0, you can say its velocity is constant. So directly I can write displacement as Vt. Uniformly accelerated motion, A is constant, and these three famous equation of motion all of you know already. So V equal to U plus AT, S equal to UT plus half AT square, V square is equal to U square plus 2AS. We are going to discuss this. Now third one is variable acceleration, where A is not constant. So here our discussion will be restricted to 1D and in some cases 2D. So V I can write as d by dt of r, where r is position vector. So in some books they will write dr by dt, somewhere it will be written as dx by dt or ds by dt. So all these three equations also I will request you to remember. A equal to dv by dt or d2r by dt square, or v dv by dr. For uniform acceleration, A is constant. From here these are the derivations. I'm not going to discuss this, but yes, you can keep this in mind. From position to velocity to acceleration, we can reach there by differentiation, and from acceleration to velocity to position or displacement, we can reach by integration. So these three equations are there. We have derived. Eliminate v and eliminate the time t, you will get the third equation. Anyways, now this is where the first part will start. The type of graph which we are going to discuss in that one is position time or displacement time graph. Next is velocity time, acceleration time, velocity displacement, acceleration displacement, and acceleration velocity. So the main points in graphs is we have to focus on two things. One is area under the curve, another one is slope of tangent. So majority of the problem will be solved by using these two concepts here. Which one is either area under the curve or slope of tangent. Now displacement vector is change in position, or you can write final position minus initial position. So let's understand the difference between position time graph and displacement time graph, where many students make mistake. So here is the first point. You can see the two graphs. In one part I have shown a graph with some offset from the origin. That means it is not starting from the origin. Another graph is starting from the origin. Now my question to you will be whether they represent position time graph or displacement time graph. So the very first thing which you will notice, the moment particle will start moving, you can say its a displacement will start. So always remember that displacement time graph will start from origin. So if I talk about this particular graph too, it is possible that it can be a position graph or it can be a displacement graph also. That means at t equal to 0, if particle will start from origin, it will have a graph like this. Whereas in second case, you can see at t equal to 0, its position is non-zero. At this non-zero position, we can say here this graph must be position time graph. It cannot be the displacement graph. Corresponding displacement time graph is going to be this particular graph, where you can easily see how this is starting from origin. So another logic which we are developing here in position time and displacement time graph, that position time graph can start from 0 or it can start from non-zero position also. But displacement time graph is always going to start from origin, which is 0 of this. So if non-zero position it will start, then parallel to this you are going to get displacement time graph, because the displacement at any time t is position vector at any time t minus initial position. So this is going to be a constant vector. This is changing with time, and this is changing with time. So these two vectors will differ by a constant vector. So that's the reason they are going to be parallel. As motion start, displacement will always start from 0. This point only we have discussed here. And here I have mentioned, if it is starting from 0, it is possible that it may be displacement and it may be position also. And the same point I have said here, one must be position time graph and two will be position or displacement. Anything is possible. And 1 to 2 conversion easily we can see since these two are parallel to each other. So first one will be position and second will be displacement for the corresponding graphs. Now next few points which all of you may already know this, like the slope of tangent of position time and displacement time graphs will give instantaneous velocity as they are always parallel to each other. And the next point is both graphs will be identical if at t equal to 0 particle is at origin. So these are the points which I have covered so far. Let's move to the next element which is required for graphs, and that is slope of tangent. So suppose RT graph is given, this black curve, and at point P you can see a tangent with the positive slope, and here this tangent is with negative slope because alpha is greater than pi and pi by 2 and theta is less than pi by 2. So this type of lines are positive slope and this one is negative slope. Next is, and yeah, this point also we have discussed, that slope of tangent on position time graph or displacement time graph is going to give us instantaneous velocity. Slope of chord here you can see, and if any position time graph is given, so this is moving in this manner, so at any time t equal to t1, let's say it is at p and its position has changed, and now position is at q. Somewhere here we can say it is at q. I hope this part is clear to you. Alright. The next point will be here, slope of chord will be change in y by change in x. So r final minus r initial divided by time taken. So slope of chord in position time graph is going to give us average velocity, which is nothing but total displacement. This is nothing but total displacement if vector wise if I am counting. Otherwise here this is r on y axis r1 and this is r on y axis for time t2. So r2 minus r1 we can write total displacement. So actually graph wise if you will see, graph wise this is the displacement. Next is distance. It is the actual path taken by the particle during the motion, and we all know that distance is greater than or equal to displacement vector its magnitude. So distance and displacement will be equal only if particle is moving in a straight line without taking turns. So whenever particle will take turn, in that case displacement will start decreasing, but the distance traveled will keep on increasing. So distance is always an increasing function. Another point is, since displacement is a vector quantity, it can be positive, it can be negative also, and displacement can be increasing or decreasing in the graphs, but the distance traveled will always increase. It will be non-decreasing function. So we can use this fact in order to convert displacement into distance graph, and we will check whether distance to displacement conversion is possible or not. So we have a very simple case. Let's say particle is starting and it's moving like this. So 0 to t1 it is going forward in a straight line motion, and then it is coming back also. So overall displacement in time t2 you can say it is 0, and total displacement in time t1 is this length. Alright, so if I have to write corresponding distance graph, because you see this is going to tell us about the decreasing displacement, but remember particle is moving here also and here also it is moving. So slope of tangent in this part is going to give us velocity and its magnitude will be the speed. So whether particle is returning, its speed is there. So we must get similar to that in displacement time graph as well as distance time graph. So here you can see, as long as graph is increasing, displacement and distance will be identical, but the moment displacement is decreasing, it's the moment displacement is decreasing, we will take its mirror image on the horizontal axis, time axis, and you can say this will represent the distance time graph. Here to here you can see easily. I hope this part is clear to you. Wherever displacement is decreasing, For the decreasing part alone, we will take the mirror image on the time axis by shifting to the point. So these are like very easy problems you can get. In one case, for 0 to t, particle is moving with constant speed and then coming back with constant speed minus v naught I cap. So velocity time, position time and distance time. So very quickly we can see, if you look at the velocity, it's constant and then negative, same value. And if we talk about displacement, so first displacement will increase and then it will decrease. So total displacement is going to be 0. It is increasing and then decreasing. Constant slope. One slope is positive, one slope is negative. Now in the decreasing part, I'll take the mirror image from the time axis and it will come like this. So distance graph. Next is, we must know how to read the graphs with increasing and decreasing slope. So you can say there are certain curves which will bend upwards and there are certain curves which will bend downwards. So the if function is increasing, without calculus I'm trying to tell you, otherwise calculus wise this will become very easy. So you can see if a graph is increasing like this, you can see slope of tangent will increase. These angles will keep on increasing. So alpha will be the smallest, then angle beta will increase, then gamma will increase. So gamma is greater than beta, greater than alpha, or we can say tan gamma is greater than beta, greater than tan gamma, or V3 is greater than V2. The corresponding speeds are V1, V2 and V3. Directly by seeing the graph, I can say that velocity at 3 is more than velocity at 2 and this is more than velocity at 1. So body is accelerating, its speed keeps on increasing. Similarly, here you can see curvature is present in the position time graph. So whenever there is curvature present in the position time graph, we will say it is accelerated motion. Like you can see here, it is opening and here again it is bending upwards. So in this case, angle alpha, at least from this part I can say, at least from in this part, it is accelerating here and here it is decelerating. All right, I hope this part is clear to you. Like this is the case of decreasing slope. So some curves will bend like this. So alpha will be large, then beta will be smaller and gamma will be smallest of all. So we can say velocity at 3 will be less than velocity at 2, which will be less than velocity at 1. So velocity at 1 will be more than 2 and it will be more than 3. So in this case, I can say 1 to 3 if body is going, like displacement is increasing, velocity is this side, but it is slowing down. This is what we call as decelerating motion. Now this xt graph is given. In my channel, another approach is also present, which I will cover in one of the videos here. So directly by seeing the xt graph, you can comment on acceleration, deceleration by using radius of curvature logic. So my suggestion would be, if you are part of my classes, you can look for Indian School of Physics channel also. There is very nice write-up on radius of curvature is present. Anyways, here I can say it is opening up xt graph. So accelerating, decelerating, constant, and in this part accelerating in negative direction, though acceleration is negative. And here again it is speeding up, basically speeding up in opposite direction, is speeding down in opposite direction, and velocity becomes 0. This is how we will read. Just by seeing the curvature of these graphs, I can comment on the velocity and on its acceleration. So it is accelerating one side, so positive. Then this is decelerating, a is negative, means positive means I'm taking this direction, then here, then a is 0, velocity is constant, and here a is negative but it is speeding up. That means velocity is this side and acceleration also this side. Here again acceleration becomes positive but velocity is negative. What is the meaning of it? That velocity is this side but acceleration has changed its direction. So easily we can see. I hope this part is clear to you. The same thing I have explained just now by just seeing the graph alone. So it depends on which direction you take positive and which direction you take negative, completely your choice. Let's move to the next conceptual point here. We can find whether initial velocity is 0 or non-zero from RT graph, its slope at t equal to 0. So if it is starting like this with the horizontal graph, we can say its initial velocity is 0. And here if it is directly going like this, so I can say initially at the initial point tangent is making non-zero angle. Here time axis is the tangent. So in both the cases I can say initial velocity is 0 and here initial velocity is non-zero. The next part, find at which point particle has the maximum speed. So slope of tangent we have to see. I think you will be convinced by this time the slope at B is largest, so maximum speed will be at B. Very easily you can say. Steepest graph you can see wherever RT graph will be steepest, that will be the point of maximum velocity. Next is three particles ABC are going along x axis, so motion in a straight line. Xt graph of particle is as shown in the figure. Their average velocities from point P to Q are average of vector V, average of vector VB, and average of vector VC. So we have to comment on, you can see xt graph is like this. So this is decelerating, this is constant velocity, and this is accelerating. But they are moving in same time to the same point. So what we can say is, in this situation, that all three will have same average velocity. Average velocity concept is total displacement by total time. So you can see here displacement is same for all and time taken is also same for all. So in this situation, it doesn't matter whether this is decelerating or moving with constant velocity or it is accelerating. In all cases, we are going to get same average velocity. So we can comment on this directly. I can mark. These are very easy problem, but conceptual problems. They will prepare you for the next advanced graph class, which I will conduct after this. Another one is displacement time graph of a particle moving in a straight line given. Choose the right answer for the distance time graph. So xt graph is given and it is given like this straight line. So very easily I can say from here you can see that this angle is alpha and this angle is beta. So till the time displacement is increasing, it is going to be same. After that, on time axis, I am going to take mirror image of this. But it is given alpha is given greater than beta. So it will go like this and bend slightly like this. So this is how distance time graph will come. So you can see 4 options are given. I can directly say this is not possible, this is not possible. One of them I have to choose. Then I have to look for angle alpha is more or beta is less. Beta is more. So this is given alpha greater than beta. So the best graph is going to be like this, which is answer for part. Third option. Next is the position time graph of two boys A and B returning home from their school to their home P and Q respectively. So A is going to P and B is going to Q. Alright. Along the straight lines as shown. So let's read the graph. Let's talk about A first. So A is constant line we are getting. So what is the meaning of this? That's the moment at t equal to 0, A is start moving towards his house and A has to reach point P. He's going closer to, and his house is very close to the school. That we can read. And time taken is same for both are reaching home at the same time. What is B doing actually? B is roaming in somewhere. He is not moving at all from the school for some time. So must be talking to his friends. You all would have come across such type of situation. Some students will leave the school immediately as soon as it gets over and directly they will reach to their homes. Whereas some students, they will have chat outside the school, wait for the bus or whatever be the reason. They will wait for some time but they are reaching same distance. Remember, B has to travel more distance, but he is reaching at the same time as A naught, so he must be moving very quickly. So let's comment on the answers. Choose the correct statement. A lives closer to the school than B. Yes. A starts from school earlier than B. This is also true. B has been waiting for some time in the school, right? Now A and B have equal average velocities from 0 to t naught. Displacement wise we have to see time is same but displacement is different. So I hope it is clear to you that both will not have same average velocity because time is same but displacements are different for both. B overtakes A on the midway. Yes, this will happen. This is the point where it will overtake because you can see they are at the same displacement. So A was moving slower, probably walking, and B waited at the school for the bus to come, and then he is crossing him in the midway. So A, B and D is the right answer. This is how you can read the graphs, and I hope you are getting the good idea how exactly we can read the graphs. Next point, for a particle moving along x-axis, its position time graph is given. So it's like one quarter of the circle, then another quarter of the circle, and then another quarter of the circle. Now we have to choose the correct statements using this data. Speed of particle is greatest at C. So C, it is horizontal, so it is definitely 0. A is wrong. Straight away I can say. Speed of particle B is greatest at B and D. Speed of particle is greatest at B and D. You can see almost vertical displacement is coming, so surely they are traveling at very high speed near B and D. So B is right. Particle is speeding up in the region CD. So C to D, yes, he is speeding up. You can see its acceleration is negative because it's coming like this, and its velocity is also x is decreasing, so it is coming down. So both acceleration velocity same side, and by slope you can see it's becoming steeper. So yes, it is speeding up. Particle is speeding up in the region CD, correct hai. Then average velocity from B to D. Average velocity from B to D, you see it's going like this, so going up and coming down. So displacement is 0 here. So if displacement is 0, average velocity is going to be 0. I hope this part is clear to you. BCD directly I can say. Next we can come to velocity time graphs. So in this we are going to see 2 points. One is slope, one is acceleration, and velocity time graph is most important of all because with the area and with the slope it will connect us to displacement as well as acceleration. So both ways it can move, so it's a most important graph. And you can see slope wise you can see, and area wise you can see here. So slope is dv by dt, which is tan theta, so it is going to give us instantaneous acceleration. That means anywhere tangent is given and it's a horizontal point, so this angle theta is going to give us, tan theta will give us slope value, which is the instantaneous velocity. Now area under the curve, v dt I can write, and I can write as dr by dt, dt is cancel. So I'll be getting integral dr, r initial to r final, and I'm going to get r final minus r initial, which is displacement. So area under the velocity time graph will give us displacement, whereas slope will give instantaneous acceleration. So these are the points which I have told you already. Velocity is a vector, so can be positive, can be negative. So acceleration 0, this will be constant. Acceleration is constant, but theta is non-zero. And here acceleration is not constant, it is speeding up. All right, variable acceleration. So conversion of velocity time graph into speed time graph we have to see. So some random graph is given like this, somewhere positive, somewhere negative. So you can see the first area is A1. Basically this will tell us displacement from year to year. Then it is negative, and velocity wise if you see, first velocity is positive. So in this zone particle is just moving in a positive x-axis. Here it stops, but keeps moving. And then if you see in this graph, it is speeding up, then speeding down, and here velocity is negative, he is turning back. I hope this part is clear to you, that velocity positive means it is speeding up, then slowing down, and again speeding up, and not turning up, speeding up, right? And this velocity is negative means velocity is changing its direction also. So two things are there. One is he is slowing down, it's almost vertical and then horizontal. Here it will stop. I hope this part is clear to you. uh, this point, this point, here at these 2 points particle will come to rest. So speeding up, not speeding up, speeding down, and then here to here starts from rest, then comes here, and then speeding down and comes to rest at this point. All right, and then again speeding up here, then comes to rest at this particular point, and then again he is speeding up. This is how we are going to read this graph. I hope this part is clear to you. Now let's check A1, A2 and A3. So and magnitude of this is going to give us instantaneous speed, and total displacement of this will be A1, this positive area, this is minus A1, minus A2, sorry, and this one is A3, I'm calling it. So if I have to write total displacement, then this will be A1 minus A2 plus A3. And if I have to write distance, this displacement in opposite direction also will be counted. So what will happen in this case? What is the meaning of this? Total distance traveled will become A1, this will become with the plus sign, and this will become A3 as it is. So A1 plus A2 plus A3. Now the same thing I have written here, area under mod Vt graph gives us distance traveled. Now mod V graph. So wherever velocity is negative, we are going to convert this into positive graph. Now this will tell us the same, because same slope we need, and because acceleration or deceleration we may have difference, and in straight line motion dv by dt and mod dv by dt, they will differ by just magnitude will be same and direction will be different. So tangential acceleration it is in general d by dt of mod v. However, in in motion in a straight line, we can say it is just magnitude of total acceleration, positive or negative. Now let's come to this part. Total distance we have calculated. Slope d by dt of mod v. Mod v, this is tangential acceleration in 2D motion. Please remember. But here we are just going to take it as related to acceleration, and that to total acceleration, because it is moving in a straight line. Now let's read the next graph. Here, P and Q are the points where particle is changing the direction. You can see positive velocity, then negative velocity, positive velocity, then negative velocity. So these are the points at which velocity is changing its direction. And if we see this point, so its motion is somewhat like it is moving in one direction. It will keep on moving. At P, it will take turn and moving in opposite direction, and then at Q, after some time, again it will turn back. All right, so something like this will be the motion of it. Now, acceleration time graph. This is also important graph, because here if you see the slope dA by dt, it is a quantity called jerk. So not so important for us, just by its unit you can check, meter per second square per second. So it is like meter per second cube. So not a famous or known quantity. So we are not going to pay attention to higher derivatives. And area is integral a dt, and this is dv by dt into dt you can cancel, integral u to v, and this will become vector v minus vector u, which is change in velocity, I hope you can understand this part. Next is velocity displacement graph. Next you can see velocity displacement graph. So this is dv by dx. Slope is dv by dx. Now this is called as velocity gradient. So it is important for us. And area is integral v dx, not so important. So these 2 points you can just check. In this graph, slope is important. Finding acceleration of particle at P and Q. Suppose this is given, dv by dx is given. All right, so here you can see this velocity is v2, let's say. This velocity is v2. And now you can see here angle, this tangent and its angle is given, tangent and its angle is given, theta 1 and theta 2 is given to you. Acceleration is v into dv by dx. This acceleration is v into dv by dx. So directly I can say at point P, the velocity multiplied by the slope of tangent at this point. So V1 tan theta 1. Similarly here, acceleration will be negative. It is decelerating. You can see dv by dx is negative in this case. So velocity multiplied by minus tan theta 2. This is going to be the acceleration at q. Directly we can mark from dv by dx v versus x graph. Next part is acceleration displacement graph. So here also we can check its slope it's not so important because slope is dA by dx and not an important quantity here. So in this case you can say it is increasing, then decreasing, increasing, decreasing, some graph is given. So area wise if we see area wise, then area is integral a dx. If we see this integral a dx, so this will become v dv by dx into dx. v dv by dx into dx. So dx gets cancelled and this will become integral v dv. So integral v dv will become v square minus u square by 2. Alright. Change in kinetic energy per unit mass. Or here we can write this. Directly at any point, if you want to calculate velocity at any point, so directly what you will do is initial velocity square plus 2 times area under the curve. Directly we will get the velocity at any point. Next is, can we convert speed time graph into velocity time graph? Now this is one question where speed time graph is given. Now many students will mark, because sir earlier we have done this question, so we may take like this, but we cannot say. The particle may move in such a way that it is let's say here moving, speeding up, then reaching its peak, then speeding down and comes to rest here, then again speeding up in the same direction or speeding up in the opposite direction. So this information, unless until it is given to us whether particle is taking turn or not, we cannot convert speed time graph into velocity time graph. And the same problem we will have with the distance time graph. Conversion into displacement is not possible because scalar to vector, we must need some intermediate point info. Without that it is not possible. Let's move to the next question. Find a point at which particle has the maximum speed. So this question I think is a repeat. We have seen already. B was the answer. This was also a repeat. Okay, these 4-5 questions are repeat. No problem. Let's move to this next problem. One VT graph is given. Find the distance and displacement in 9 seconds. So you can check here. Now, by seeing the graph, this is 2 unit and this is 2 unit, and plus 10 to minus 10, I can say if this area is A1, this area is A2, this area will be minus A2 actually. This area will be minus A2. Yes or no? I think easily you can comment on this. So let's check this area, how much it will come. Half base into height, this will come 25, and half base into height, this will come 10 units, and this will come minus 10 unit. So displacement wise I can say 25 plus 10 minus 10, 25 will come displacement. And whereas distance 25, 10 and 10. The graph also you can make like this. This is speed time graph. Its area we can take. So distance is 45 and displacement is 25. So very easy example. Now for this problem we can say, for a particle moving in a straight line, Vx graph is given. Vx is a circle of radius 2 units and its center is at 2, 0. Then the acceleration of this particle at 2 minus root 2, root 2 will be. Now in this problem you can see that one approach is writing its function and then we can solve this. However, it is not advisable. Reason is because everyone will be solving by that logic in this particular problem. It may work, but if I give some other curve or some other relation, then writing equations will not be a good idea in my opinion. Let's find out. So here you can say Vx graph is given, so acceleration is V into dV by dx. So in this problem, values are set in such a way that you can see 2 minus root 2 comma root 2, and center is at 2 comma 0. So this distance is 2, and this point is 2 root 2, so remaining is root 2, and this distance is 2, so this distance is root 2. Such a nice values are given, means this angle is 45 here, tangent is making angle of 45. So if this is root 2, we know the velocity value, which is root 2. So acceleration is V, which is root 2 into dV by dx is tan 45, which is 1 root 2 meter per second squared. Directly we can write the answer, and we can reach here quickly. Now in the next part, example, for a particle moving along a straight line, Vx graph is shown. So you can see here, this is Vx graph straight line. This is, by the way, JEE advanced problem. So we have to plot its Ax graph. So first thing is we can use V by V naught plus X by X naught equal to 1 as equation of straight line. So V we know already. Now I can write from here dV by dx is minus V naught by X naught. You can write dV by dx is minus V naught by X naught. And after that, I will use the information that V is equal to, acceleration is equal to V into dV by dx. V value I know, dV by dx I know. One by one I will substitute here, and I'll be getting A is equal to plus of V naught square by X naught square into X minus V naught square by X. So this is in the line of Y equal to mx plus C. So this is the graph here. Easy, right? Then the next graph is V square versus X graph. Here area is not so important for us because it is integral V square dx. So we can cancel this out. However, slope, if you see, that is d by dx of V square, and it will be 2 into V dV by dx. So slope of this will be 2 times of acceleration. Very nice. Slope is important for this graph. Area is not. You can check here. Vx graph is given, V square X graph is given, and they're asking us particle moving in a straight line at x equal to 0. So Vx graph acceleration, just now we have calculated from the previous equation, V into dV by dx. V into dV by dx. So just see, it's so dV by dx is minus 2 by 5, and V value at that point is 2. So minus 4 by 5, 40 by 5, sorry. So minus 8. Similarly, V square X graph, so that is 2 times of V dV by dx. So its slope is double of acceleration. So slope is minus 2 by 5, and double of that you can see here, that is 2a. So minus 2 by 5 is 2a. So a is minus 1 by 5 square. So this is going to be the answer. Now this problem is given for a particle moving in a straight line. Ax graph is shown at t equal to 0. Particle is moving with the 3 meter per second speed. At t equal to 0, velocity is given here at this particular point. Find the speed of particle at x equal to 5. So I have told you area under Ax graph is change in velocity square by 2. So I can write velocity at 5 square minus 9. You can say velocity square minus 9 divided by 2 is equal to area of triangle plus area of this A1 plus A2. Directly I will get the answer. So here you can check, V square minus 9 by 2 is equal to half base into height plus length into width. If you simplify, you will get root 33 meter per second. So guys, this is it in this video, and I will come up with the more advanced problem for the next phase, because this is, I think, easy part. All basic points I have covered in the graphs, so only its application in complicated situations is required. So just revise this so that you'll feel comfortable in the next lecture which will come very soon. And thank you.